Why I start. Okay, now we're gonna get started. So today we're gonna do 11.2, which is geometric sequences. Okay, like we talked about on the warm-up, we saw that it was multiplying by 2 each time instead of adding by 2 or subtracting by 2. That was arithmetic sequences, adding or subtracting by the same number. Now for multiplying by the same number, it is called a geometric sequence, and Jordan and Kai both established that means it's exponential. Okay, if you're multiplying by something every single time, it's going to grow really quickly or go down really quickly. Okay, and then also if it's arithmetic, that was linear. Okay, it had that constant change of adding or subtracting. Okay, maybe we add that in the little words over here. This one was linear. I like that y'all pointed that out. Because on Friday, we will start specifically talking about exponential functions, graphing them, equations of those. So this is a good little preview or talk about before we do exponential functions. Okay. 11.2 geometric sequence, it's only going to be one page. Okay, it's only on one page. So turn to that page. Let's see, that was yesterday's 64. Now I got 65. Okay, get that glued in if you don't already. I don't, so bear with me. While I'm thinking about it, make sure you get your quotes in this week, 8th grade quotes. And also, I have tutoring today from 3 to 4:15. Today it's going to be in the conference room. I'm going to try to find a different spot so I haven't come all the way up to my classroom. But today we're in the conference room after school. All right. Yes. You didn't give one? Sorry. I just walked all the way around you and then forgot to give you one. There you go. Okay, so you can either glue that in now or glue it in after we discuss it. I don't want that color. Okay, so a sequence is geometric. Okay, these notes aren't as long because we kind of know what sequences are and the sequence notation. So we're just going to do 2 examples and talk about this new formula. Okay. So a sequence is geometric if there is a common, not difference, but a common factor, or you'll hear a common multiplier, or a common ratio. Those are all the things you can hear. Okay, common factor, multiplying by the same number each time. Common, what's another word for this? Multiplier. Okay, you're multiplying by the same number each time. Or ratio, because maybe you're multiplying it by a fraction and it's getting smaller and smaller and smaller each time. Okay, so that's why you're here any of those. So it says if you see any 3 of those, common factor, common ratio, common multiplier, that means you're multiplying by something each time, whether it be a whole number or a fraction. Okay. Between the terms. Okay. We know what a sub n is. Okay, that is the term of the sequence that you're looking for. Okay, so the sequence term for whatever n is. What does a sub 1 stand for?
The first number of sequence.
Yeah, the first, we'll say term. We'll get fancy with it. But yes, it's the first number in the sequence, aka first term. Okay, first term, first number in the sequence. Okay, what's that little dot mean? Times. We're multiplying. Okay. I want you to put the R in parentheses. Put parentheses around the R. That's because sometimes that common ratio, we got a nice letter there. R stands for common ratio. That is sometimes negative. And when you substitute that in, if you have a number and then you just put, let's say it's -2 each time, you're multiplying by -2. If you put 10 minus 2, it looks like you're subtracting. You're supposed to be multiplying. So maybe if you put parentheses around it, you'll know you're doing that first term times whatever it is. And that R stands for the common ratio, common factor, common multiplier, all of those things. But it's an R. Okay. And then n minus 1. And all of that is in the parentheses at the exponent. Okay, this is as an exponent. The whole thing is an exponent. So whatever the n value is, let's say the n value is 6, what would be my exponent? 5. Okay. This is where that little raise to button on your calculator, it looks like a roof, is going to come in handy. Okay, you're going to need your graphing calculators for these because it's not so easy to do all that. If it's exponential, it's not going to be very easy to calculate in your brain, in your head, mental math. All right, let's do some examples now. Same wording. We're still writing that explicit formula that is solely for this sequence, but now it's a geometric sequence. Okay, and once we have that explicit formula, then we're going to find the 16th term. Okay? So we kind of got two parts here. First, we got to write the formula. Then we're going to find the 16th term. Okay? So to be able to know these things, or be able to calculate this stuff up here for that term sequence, I need to know a sub 1. What is a sub 1 in my sequence? 5, yes, that first term, that first number. Okay.
Ms. Taylor?
Yes.
What means Zoom?
Oh, yes. Thank you. Yeah, I don't know why, but it didn't connect. It didn't give me a little ding ding. Oh, probably because my volume's all the way down. There we go. All right. What is my common ratio, or what is my R equal? What's happening each time? Okay, because it looks like, oh, we're adding by 5, but that's just the first one. It's not plus 5 each time, so it's times 2. I don't know, how do you want to do it? Y'all like the X? A dot 2 might look like a decimal, so times 2, times 2, times 2, times 2 each time. So I'm going to put in parentheses here, times 2, okay? My common ratio is multiplying by 2 each time. Okay. So first, let's write the explicit formula. So I have a sub n, and the explicit formula means the n's are there, so that you can do it for any nth term, any number of term. The first term is 5. In parentheses is a 2. That's my common ratio. My exponent is going to be n minus 1. That is the explicit formula. Okay. That's the explicit formula. That you can find any number of term when you have that. Okay? Gabe, I like how you circled that. I'm going to circle that. That is the explicit formula. Now that I have that, so very much similar to the common or the arithmetic one. You have to know the first term, and you have to know the common difference or common factor. Okay? And then the n's are there. But the other stuff looks a little different. Now I'm going to find the 16th term. So now I want to find it when n equals 16. So now I'm going to take my explicit formula for this geometric sequence, substituting in 16. So a sub 16 equals 5 times 2 to the 16 minus 1. Of this formula, the 5 times 2 raised to the 16 minus 1, how do I start? What do I do first? 16 minus 1. Yes, so I'm going to do the 16 minus 1 first. Okay, so now I have a sub 16 equals 5 times 2 raised to the 15th power. Now what do I do? Do I do 5 times 2, or do I 2 raised to the 15th? It is so easy. You guys are correct. It is so easy to make the mistake and do 5 times 2 first. You do the exponent first. I'm not even going to act like my brain knows what that is. What is 2? In your calculator, you're going to do 2, and then that little rooftop button, and then the 15. What does that give you? 32,768. 32,768. All right. So now a sub 16 equals 5 times 32, 768. Now hit times 5. I know it ends in a 0. That's all I know. Gabe, you want to tell me that number? I knew it ended in a 0. And that's the term. The 16th term of that sequence is very large compared. We started out with 5. The 16th term is over 100,000. Why does it become so large? It's multiplying by itself each time, right? And at each time that it gets multiplied, it's growing bigger and bigger. So first we did 5 times, multiply by 2. 5 times 2, and then 10 times 2, and then 20 times 2, or whatever the number is. I can't say it. Yeah, 20 times 2. So it's multiplying by 2 each time, but the number being multiplied has grown. This is exponential. Okay, my variable is in the exponent. Okay, the 15, that was the variable. That's in the exponent. It's going to grow quickly. Okay. Example number 2. There's the EX there. Sorry, I got cut off. Okay. Evan. Write the explicit formula for this geometric sequence. And then determine the value of f of 9. What is that? What do you think that means? F of 9. What am I looking for? The 9th term. Yes, this is when n equals 9. Good job. Okay. So first we're going to write the explicit formula just like we did up here. So I need to know some things. I need to know a sub 1 and I need to know the common ratio. A sub 1. Kai, what is a sub 1?
A sub 1 is
48. Perfect. All right, what's that common ratio? Divide by -2, or I could say multiply by what? Because you want to think of a common multiplier. That's why it's also a common ratio. You want to change that to the fraction. So it is divide by 2, but what can you change that to be multiplying by? Oh yeah, negative. So I'm going to say even -1/2 or -0.5, yeah. You want to change it to a multiplier because in our formula, it's a common multiplier. Okay, so you can't change it to dividing with this one here because it has the exponent first. So change it to be multiplying by -0.5 or times -1/2. So -1/2. It's halving each time with the negative because the sign's changing. Okay, good noticing there. Let's fill this in now. A sub n, so I'm writing the explicit formula first. I want to leave my n's as n's. Let's assume we don't know that n is 9 yet. All right. And then my first term was 48. Common ratio is -1/2. And then n minus 1. That was that explicit formula. All right, having at your calculators now, let's start plugging things in. So f of 9 means n is 9, okay, because n's in the parentheses or n is a subscript. So I'm looking for a sub 9, which gives me 48 -1/2. I'm going to do 9 minus 1. For the sake of notes, I'm doing 9 minus 1 so you know where the 8 came from. Moving forward, you can just put 8. I know that 9 minus 1 is 8. Okay, then I'm going to do the 9 minus 1 first. So a sub 9 is equal to 48 times -1/2 raised to the 8. You have to do the exponent first. So I'm running off my paper. A sub 9 is equal to 48. What is -1/2 raised to the 8th power? In the calculator, you can put -0.5, raise it to the 8, or -1 divided by 2. raised to the 8th. What do we get? Gabe, you're my calculator. What do we get? So you have to put parentheses around that -1/2, or it's going to do 2 raised to the 8th, and then it's going to do -1 divided by that number. Did you put parentheses? No. You didn't put parentheses? Oh, I know, I can't get there. So if you got to put parentheses if it's a fraction, because order of operations, if you don't, it's going to do the exponent first, then the division. We want to do the division first, and then the exponent. Okay, it's probably a good thing if I show this. I'm gonna use your calculator.
That's the same.
Okay, so what you got? Okay, so if I put this in the calculator, y'all see this on the screen? You're like, crap, I can't write that number down. What do? Do y'all remember that math button? Math, enter, changes the answer into a fraction. Enter, look at that, 1/256. I can write that down. 1/256. So now I got 48 times that. You hit the math button. The math button changes numbers between fractions, decimals. You can cube something, the cube root, any root. Okay, that math button's really good. That's your BFF right there. Fractions and decimals, that's your best friend. Then I'm going to take that number and multiply it by 48. Oh, I don't like that number either. What can I do? Hit the math button, enter. 3/16. A to the 9th. The 9th term is 3/16. And you'll notice this sequence was getting smaller and smaller and smaller and halving, so you should get a small number. Okay. Remember, push that math button. That math button will turn it into a fraction. Okay, that's maybe we'll highlight that in your notes. That math button is beautiful. Math button is beautiful. I mean, you could have wrote it as a decimal, but let's say you wrote 0.1875 and it's multiple choice and you're like, where the heck's that answer? Hit math, enter, get the fraction answer. Okay. Yes, Lander. Okay. That is it for notes. I have done another little fun screenshot stuff from Khan Academy because they had recursive in there. When you finish the explicit formulas, I might have you challenge yourself and try recursive formulas on Excel and see if you can figure it out, because you're going to see those, just not right now. Okay. That is it for my Zoom.